So let's try to do some substitution problems where our u and our du may not be exactly what we need. We might need to do a little manipulation. So if I were taking the derivative of this, right, I would see the outside function is sine, and then I would just kind of have stuff in the middle. So the easier way when we're dealing with these indefinite integrals using substitution is just call all the stuff in the parentheses u. It's a good place to start. So my u is going to be 3x plus 5. Our du is 3 dx. So the next step is to make the substitution. But I have everything I need to substitute the u, but I don't have the 3 dx. So what I like to do is solve this equation for what you actually have. So the only thing of this equation, right, that I actually have up here is the dx. I don't have the extra 3. So if I say, well, du over 3 equals dx. So now when I substitute, I'll get the integral of sine of u times du over 3. So I can just put the 3 right here. So then I'm going to factor my 1/3 out front. And now I'm going to integrate sine of u du, and I get negative cosine of u plus c. And we want our answer to be in terms of x, so now I just plug back in what u is taking the placeholder for. And if you compute the derivative of this, it is in fact this. All right, let's look at another one. So here, I've got the more complicated side of this, right, is all this stuff under the radical. So I'm going to start by letting that be my u. So 1 minus e to the 2x. So now if I take the derivative of that expression, I get negative e to the 2x, right, and then times the derivative of the inside, which is 2. So I do not have, I have a negative sign right here. I have an e to the x. I don't have an e to the 2x. So let's try another u, because this one didn't quite get it done. So if I look at this, this sort of looks like a derivative I've seen before. What if I write this as, pull the negative 5 out front, and what if I write this like this? E to the 2x is the same thing as saying e to the x squared. So now let's write u as e to the x. So then my du is e to the x dx. So see, if I had tried to use the entire expression, I didn't have a 2x up there and there was no way I could make one. So I wanted to show you that sometimes what might seem like the obvious choice, right? You always want to test it and you're like, oh, maybe I can do better. So now if we let this be e to the x dx, well, there's my e to the x dx, there's my du, and now I can rewrite this in terms of u. So if we rewrite it in terms of u, we have negative 5 times the integral of 1 over 1 minus u squared du. Now I recognize this derivative. This is the derivative of arc cosine, or arc sine. So negative 5 arc sine of u plus c, and now I plug back in what my u stood for. So on this one, because this one's a little bit different than we did before, let's just double check that we actually get our correct answer back when we take the derivative. So it's negative 5 times 1 over 1 minus e to the x squared, all under a square root, and then I have to multiply this times the derivative of the inside. And that is negative e, or negative 5 e to the x over 1 minus e to the 2x. So this is, in fact, going to give us the antiderivative. So if you have an e to the 2x in the denominator, but you only have an e to the x in the numerator, that's how we knew to rewrite it as that guy squared.